All right, this morning I'd like to do a little conversation about gravity. Okay, we're not going to get too complicated with this. However, would like to go over a couple points. If you have two objects, okay, let's say M1 and M2. M standing just for mass. We'll judge the distance between them from the center of mass of M1 to the center of mass M2. And now Newton, his law of universal gravitation looks like this. Okay, R being this distance here, M1 and M2 just being the masses of each object respectively in regards to kilograms, and G is 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. Okay, now honestly, the most difficult part of these problems doesn't come from the equation as much as it comes from just plugging in your numbers correctly into the calculator. It's pretty easy, honestly. Let's say we just make up numbers, but if I have two masses, we can say even something like the mass of our Earth. So, mass of our Earth is roughly 6 times 10 to the 24, so 6 times 10 to the 24. And I want to know what the gravitational influence is in regards to putting, let's say, a 10 kilogram rock, okay, on the surface, right? You plug in your radius here, squared, and then your 6.67 times 10 to the negative 11 up here. Excuse the bad handwriting. Now, and then you'll get whatever your force is. When you plug it into your calculator, number one most missed thing, at least in previous years, is that when they divide this number right here, many times can be quite large. So something by 10 to something power. And so if you're using such a large number, you need to make sure you keep it in parentheses. And then on top of it, I would put a double parentheses around the whole thing. That way it keeps the squared only on the denominator. It keeps you from getting erroneous answers. Okay. A really common thing to ask for is for us to ask for the radius. In this case, asking for R. If you rearrange, you just times the R over and divide the FG down. So you get R squared is equal to G M1 M2 over FG, and then you have to square root both sides. A lot of people forget to do the square root, so be careful, make sure you do that. Then other people wonder, well, what's FG? Usually if we're doing a problem like this, we can get our FG, okay, through just F equals ma. We've been calculating gravity, at least the force of gravity, for a couple of months now, just using Newton's second law. In this case, it would be the force of gravity when we have the acceleration of gravity attached. And so you can substitute this in right there. So Fg really can equal Gm1 M2 divided by R squared, and it can equal the mass of whatever the object is we're looking at in regards to Earth times the acceleration of gravity there. Okay, so we could use that, and that helps us. The other types of problems that we'll find, and that most people struggle with on the test, are in regards to what we call inverse square laws. Now, an inverse square law is not in regards to just this equation, but it is in regards to anything like that has this 1 over r squared. Okay, so usually in inverse square law they'll say is 1 divided by d squared. Okay, so in this case d would be r, but we'll use this equation many times when we talk about electricity as well, because the relationship is an inverse square law there in regards to what kind of force you experience between two electrically or magnetically charged objects. Okay. So let's keep with this idea. We got two objects, okay, and we got some distance, yay, r between them. Let's just say that there's a bombing 10 newtons of gravity between the two. So that 10 newtons represents this entire equation here, okay, and I just tell you that I'm going to double the distance. So instead of it being from just this r here to between these two objects, I'm going to take this object, I'm going to extend it out a full another r. And I just want to know what's the force now. If it was 10 newtons at this distance, what's the force at double the distance between them, gravitationally speaking? And so a lot of people would just be like, well, it's 5. You've doubled the distance, so the force will be cut in half. But it's an inverse squared relationship, okay? The square is the important part there. So what you do, and this is just real simple, you go 10, so you stick with your original value, and then you just times it by the inverse, by the law, okay, the inverse square law. And so I've doubled my radius, so I'll put a 2 there and keep the squared. And so it's 10 times 1/4 now. And so I get a value of 2.5 newtons. Okay. So if I was to say let's quadruple the distance between the two objects. Okay, so make it 4 times the distance, then I'll put a 4 there. So in this case, 10 divided by 16. Now, what if I was to get closer? Okay, per se, let's say I go, well, let's take this guy and drop him halfway the distance. So he's actually quite a bit closer. So you keep with the same idea and you go 1 divided by 1/2 the original distance squared. Okay, and that turns into 40 newtons. Or 1/3 the original distance. So you do 1/3. Sorry. So, and that's really the clincher, okay? You're going to use whole numbers if you're going farther away. You're going to use fractions if you get closer together. All right? It's really just that simple. Most people get really confused about it, but don't let this confuse you. All right? The best way to get comfortable with these types of problems is to just get out your homework and give it a shot. I know that sounds kind of but it's really important for you to practice and practice and practice, especially putting in your numbers correctly into this equation. All right. If you have any questions or concerns, feel free to reach out to me. Either be via email or come in before or after school. I'd love to help you. Hope this helps.